We've all seen rusty iron and steel, and we've all had to replace worn-out batteries. These two things have something in common. They are both the result of a natural process we call corrosion. A rusty piece of steel, if left alone long enough, completely dissolves away. The steel is returning to its original form. It started out as iron ore mined from the earth. It was mixed with other ingredients, heated, blasted, cast, hammered, and rolled into a useful shape. It took a lot of energy to do that, and the energy remains pent up, so to speak, in that piece of steel. Nature wants to release that energy and return the steel to the iron oxides found in the ore. So when conditions are right, the steel rusts away. Actually, corrosion affects almost all metals with the exception of the precious metals like gold. The corrosion cell. For serious corrosion to happen to a piece of steel, it must be part of a corrosion cell. A corrosion cell has 4 parts: an anode, a cathode, an electrical contact between them, and an electrolyte. An electrolyte is a substance with low electrical resistivity that surrounds the anode and cathode. When the cell is complete, there is an electrical current flow from the anode to the cathode. This happens because the anode and cathode are 2 different metals that require different amounts of energy to be processed from ore. They present each other with an energy difference, or an electrical potential difference. When the current flows, it causes corrosion damage to the anode. Unfortunately, a guide tower anchor is a great example of a corrosion cell. The steel anchor shaft is the anode, the copper grounding is the cathode. The anchor shaft is electrically connected to the grounding, and the anchor and grounding are buried in the soil, the electrolyte. AnchorGuard. Obviously, at a guide tower anchor, we don't want to see corrosion damage the anchor shaft. One very effective means to prevent this is the sacrificial anode. Exactly as the name suggests, we bury and connect another type of metal that becomes the anode of the corrosion cell. As long as that anode is properly in place, it will corrode instead of the steel and preserve the anchor and grounding. Earlier, we mentioned worn-out batteries. A battery is a self-contained corrosion cell missing one element: the electrical contact between the anode and cathode. When we install a battery and turn on the device, contact is made, the cell is complete, and there is a measurable electrical current. When the anode corrodes away, the battery dies. The AnchorGuard system is a pre-engineered package of sacrificial anodes designed specifically for guide tower anchors. Just like a battery, the electrical current of the AnchorGuard system will die out as the anodes corrode away. That's why the system comes with a built-in means of testing the electrical current to determine the strength and life of the anodes. Installation procedure. An AnchorGuard system comes in one crate and has everything needed to protect a set of 3 anchors, 3 test heads, 9 anodes, and a set of installation instructions which contains a data table to record the results of system testing. Step 1. Lay out the locations of the holes for the anodes and the reference half cell according to the drawing. Slight adjustments can be made to avoid obstacles above and below grade. Step 2. Bring in the auger. Using an 8-inch bit capable of going 6 feet deep, drill the anode holes to a finished depth of 6 feet and the reference half cell hole to a finished depth of 5 feet. Step 3. Remove the anode from the plastic bag and uncoil the lead. Place the anodes into the holes. Backfill and tap the soil around the anode up to the level of the top of the anode. In order to help the connection between the anode and the surrounding soil, add a few gallons of water to the hole and let it soak in. Step 4. Place the half cell. Backfill and tap over the top of the half cell. After the anodes and half cell have been placed, dig small trenches from each hole as directly as possible to the point of daylight of the anchor shaft. The trenches should be 12 inches deep. Step 5. Attach the test head to the back of the fan plate. Attach the anode leads to the test head and secure them with a zip tie. Lay all of the leads into the bottom of the trenches, starting at the test head, and coil the excess into the tops of the holes. Step 6. Backfill and compact all the holes and trenches. System testing. There are 3 tests that can be performed with the AnchorGuard test head once the system has been installed. These tests can be used to monitor the condition of the anodes over time, so replacement can be made before they fail. AnchorGuard recommends recording the test results on the installation instructions and keeping them on file. An initial run of these tests should be done as close to the time of system installation as possible, but allowing time for the system to fully interact with the soil. This can take up to 3 months, but it can be helped along by pouring water into the anode and test head holes while adding the backfill. We will describe the condition of the anodes as 3 levels of performance: good, degraded, or depleted. Good is obviously what we want, full protection. Degraded is still providing protection but falling below optimum levels. Depleted is no longer providing protection. The only tools required for testing are a digital voltmeter that can read DC millivolts and a small adjustable wrench. Make sure that the test head clamp bolt is tight and secure to the anchor fan plate. Make sure that the anode lug nut is also tight and that the anode's leads are secure to the test head. System performance test. This is the most important measurement because it tells the overall performance of the system. This should be checked yearly to monitor the system over time. Set the voltmeter to DC volts. Place the negative lead on test point C and the positive on test point G. The meter will read a negative number. Record the reading. A reading between negative 1.35 volts and negative 0.85 volts is normal for anodes in good condition. Readings between negative 0.85 volts and negative 0.60 volts tell us that the anodes are in a degraded state, and negative 0.60 volts or less is a sign that the anodes are depleted. Instant off test. If the system performance test is below the good range, less than negative 0.85 volts, the instant off test can help determine if the anchor shaft is still being protected and whether or not the anode is depleted or just degraded. For this test, we will be disconnecting the anodes and checking the voltage instantly after the disconnect. Keep the voltmeter set to DC volts. Loosen the anode lug nut so that it can be removed. Just like the performance test, place the negative lead on test point C and the positive on test point G. The meter will read a negative number. If possible, while holding the leads on the test points, quickly remove the anode leads and observe the voltmeter readings. Depending on the condition of the anodes, the reading will drop rapidly at first, then slow down, but continue to drop. It will happen fast, but read the voltmeter the instant the anode is disconnected for the most accurate result. Record the reading. Then subtract the voltmeter reading of the system performance test from the instant off test reading. The difference of the two recordings should fall between 0.1 and 0.3 volts. The higher the better. A difference of less than 0.1 volts indicates that the anodes are degraded, but protection is still adequate, but plans should be made to replace them. A reading of 0 means that the anodes are depleted and immediate replacement is required. The anchor shafts are no longer being protected. System life test. This test is used to estimate the projected lifetime of the anodes. It should be done as close to the system install date as possible since the calculations are based on uncorroded anode weight. But remember that the system does need some time to fully interact with the soil. Set the voltmeter to DC millivolts. The reading will be very small. Place the negative lead on the S1 test point and the positive lead on the S2 test point. Record the reading. Enter the reading on the anode life calculator found on the AnchorGuard website to find the estimated lifetime. The lower the voltage reading, the longer the system life. Unexpected readings. If placing the voltmeter on the test points for the system performance test results in a 0 or close to 0 result, there are a few possibilities. The voltmeter leads are not making good contact with the test points. Clean the test points and check the function of the voltmeter, and make good contact with the leads. The test head clamp or the anode connection lug are not secure. Make sure they are seated properly and tightened securely. The anode and/or test head leads have been cut. Inspect them fully. In the event that none of these is a problem, the test head could be defective and should be replaced. If readings are unusually low or do not behave close to what is expected, the buried portion of the test head may be damaged or defective, and the test head should be replaced. Guy anchor shafts are a structural element of the tower and should not be compromised by corrosion. They often fall into the out of sight, out of mind category. But if the bottom 8 feet of the tower steel was as corroded as some guy anchor shafts we've found, swift action would be taken to remedy the situation. AnchorGuard is the remedy, and more importantly, the preventative.